This section gives a brief introduction to state machines. State machine is a good way to express high-level logic using the diagram. It can be used in a lot of different ways, for example AI logic. uFrame has a built-in support for state machines. Let's see how it works. In this example, I have two elements, simple AI and victim. Victim has a scene property called avatar position. Simple AI has a scene property called distance to victim. Both of scene properties are already implemented. I have a link to the victim and relax command. For this simple AI, we're going to create a state system based on the distance to victim. To do this, I first have to create a state machine node. I can go inside my element, right-click, and add state machine. I'm going to name this AI state machine. Now I have to introduce a property on my simple AI and link it to the state machine. As you can see, now the type of the property is AI state machine. Double-click on the state machine and you can start designing your states. In my case, I'm going to introduce 4 states. First one is going to be relaxed. Next one is going to be alarmed. Next one is going to be attack player. And the last one is going to be chase player. Now, when we have states defined, we're going to define a few transitions. If I drag the output connector of my state machine to some state, this is going to be my default state. So whenever my enemy appears, it's going to be in a relaxed state. Well, whenever I see the player, or the player is in spot range, I'm going to chase him. So I'm going to add a transition here. Now I can pick it here and drag it to chase player. While I'm chasing the player, I may once be able to attack it. So I will add another transition called can attack player. And do the same. But now I will go to attack player state. Well, when we're attacking the player, suddenly he may run away, so I will not be able to attack him. So I will add can't attack player transition. I will pick it here and drag to chase player again. Well, at some point, player can run too far away. So I will add another transition called player lost. And here, if I lose the player, I'm going to go to alarmed state because I want to stay alarmed for a while. Finally, at some point, I might say, oh, okay, I'm gonna relax because the player is too far away. So I will introduce relax transition. Pick it up here and drag to relaxed state. Well, now we have states and we have transitions defined. So how do we actually trigger the transition? Well, for this, you can use either command, like this command relax here. I'm going to drag it to relax transition, and now whenever I'm in alarmed state and relax command is executed, I'm going to transition to relaxed state. For more complex logic, you can introduce computed properties which are booleans. Well, let's say I have a computed property called player in attack range. And this can be easily dragged to can attack player because, yeah, whenever player is in attack range, we can attack him. This one, of course, is going to be dependent on distance to victim. Using the same logic, I can define another computed property called player out of attack range. This one is going to be dependent on the previous one because it's just an invert of this expression. And I'm going to drag it to can't attack player. Also, I will add something like player in spot range. This one again is going to be dependent on distance to victim, and whenever player is in spot range, it means that player is spotted. Finally, player can be out of spot range. This is again just an invert of this expression, and I'm going to drag it to player lost. Let's also fix the issue here with the alarm state, because whenever the player is spotted again, I'm going to transition back to chase player. And here you can see how you can reuse different transitions for different states. And back to our computeds. Those are of Boolean types, and that's why they can serve as so-called triggers for state machines transitions. In this case, whenever the value is set to true, it's going to invoke the corresponding transitions or transition. Now we have logic implemented on the diagram, let's also implement it in the code. I will go to my view model and paste my computeds here. As you can see, the attack range is considered to be less than 3 and the spot range is considered to be less than 10. The rest of the guys are just inverts of the corresponding properties, and I can rely on those because I have those dependencies. In my scene, I already have enemy prepared with the link to the player. If I hit play, and actually I have to unlock this guy, you can see that once I start moving the square, the things are changing here. When debugging your states, you can use either this state property here in the view inspector, or you can dock the diagram window somewhere. Choose your state machine diagram, and once you have an object selected with this state machine, you will be able to track all the transitions and all the states. Well, it's all nice and fancy, but it's not much of a use if we cannot rely on those states in the view or in the controller. Let's start with the view. If you have a view connected to your element and you open the Add New Binding window, under the State Machine property binding, you will find State Change, which stands for this state here. I'm going to add this to my view. Hit save and compile. And open my view. Well, here I got a bunch of stuff generated. First of all, I have this state changed. But also, for the sake of convenience, you have all the handlers for different states generated. Here I have a sprite property and I cache it on the wake method. And I'm going to use it to provide some sort of visual feedback. I'm simply going to change the color of my sprite. Now if I go to my scene and start dragging this guy around, you can see that it changes color. And I can execute relax to make him greenish. uFrame also allows you to define any additional logic related to your state machine. Let me go to my simple AI controller. Here, whenever I initialize simple AI view model, I can grab its state property and subscribe to it. I will get my new state here, and I will execute a handler. Inside of it, I'm going to figure out if my state is alarmed. If it is, I'm going to create a timer. Let's set it to 3 seconds. Whenever the timer finishes, I'm going to execute command on my simple AI called relaxed or relax. So now if my AI enters alarm state, it's gonna wait a bit and start relaxing.